Hello, and thank you for coming to my presentation. My name is Anastasia Montgomery, and I will be presenting on the co-benefits of electrifying Chicago's municipal vehicle fleet. I study air quality, which is not uniquely an urban problem, but it seems to be integral to the way of living in a city. We see high-emitting sources like cars and power plants situated closely with high-density populations. For this study, I focus on Chicago, which has been in ozone non-attainment since 2012. And to target pollution as well as climate benefits, the city has proposed the electrification of passenger buses. Our experiment takes this policy one step further. To set up this experiment, we use a chemical transport model called WRF-CMAC to simulate one representative summer month and one representative winter month at a 1.3 kilometer spatial resolution, so that we can highlight neighborhood scale changes in air quality. For the electric vehicle scenario, we remove tailpipe emissions from a variety of municipal vehicles and perform 4 experiments: the electrification of school buses, passenger buses, all municipal vehicles, and school buses with light-duty vehicles. We then apply health response functions. As shown in this figure, we have the changes in atmospheric composition from the all-electric municipal vehicle scenario. Here, we show the changes in nitrogen dioxide, ozone, and particulate matter over the city of Chicago with neighborhoods outlined in black. And it's true, we remove municipal vehicle emissions and actually see an increase in ozone. This is because ozone is a secondary pollutant that depends on the emissions of NOx and volatile organic carbon emissions in a nonlinear fashion. Because of this relationship, this urban environment is NOx saturated. This just means that if we remove enough NOx from a NOx saturated environment, we actually end up creating an environment that destroys less ozone. This effect is known as the weekend effect, because ozone increases on the weekends in cities because we do not experience rush hour traffic. Applying the health response functions, we see that the benefits of electrifying municipal vehicles end up overcoming the increase in ozone. There's a 1.4% reduction in CO2, and the avoided premature mortality results in $41 million in health savings. And expanding this analysis across all experiments, we show that the simulated pollutant changes resulted in both positive and negative chemical changes that were largely offsetting. Across all experiments, we get the weekend effect with increased ozone, so health outcomes were dependent on the changes in particulate matter. While the largest change in pollutants were observed with the electrification of municipal vehicles, the best health outcomes were observed with the electrification of school buses. Every policy reduced CO2 emissions, thus indicating that most of these policies were beneficial from a health and climate perspective. I would like to thank my co-authors for their work, and SF for the funding, and I will be available for questions via email. Thank you.